we're going to revise this GCSE required practical that you did, yeah? So I've got 5 resistors here of identical value. You measured that earlier, which was what, around 68 ohms. So I'm going to try and connect them in series and then do the same for parallel and see the relationship, okay? I'm going to connect. So you can all see that I've actually connected all the 5 resistors in loop. Actually, I missed one, so there's another one here. 5 resistors in series. We know that the value is actually 68, but I'm going to try and keep it around 70, right? Round it up, 70. And I now need my ohmmeter. So I'm going to put my ohmmeter up to 200, and I'm going to try and connect that. So what value do I get? Bigger than 200. Around, what's that? So it's up to 2000. So what's the value? 340. 340? 340 for how many resistors? 5. And if we keep going like this, and I'm going to take one off. What value am I getting for 4 now? Taking one off. Can we read it off? 271. Take the next one off. How many have I got? Value now. Okay, 135. And then what? 68. Yeah? You could see the proportion here, doubling, and it just keeps going up what? In increment of 70. So what relationship does that prove? In series circuits, your total resistance is equal to what? Just R1 plus R2 plus R3 plus, and whatever value you've got, because those were all identical resistors, you could say if I've got 5 resistors, then it's 5 times R. Generally the expression is NR if they're all identical. But there's going to be another relationship that we're going to prove now with the parallel one. And the parallel one's a bit more tricky, and I'm going to give you a little formula for you to remember. So the next one is now having the resistors in parallel. So what's the value for that one? 70. Okay, so we're going to plug in another one just in parallel. I'm just going to loop them all. What's the value now? 34. Half of 70, around 34, 35. Another one. Oh, does it matter actually if I do parallel to this one? It doesn't really matter, okay? That's another one. What's the value now? 20? 23.7. Okay, I'm going to write it as 23.7. Actually, I'm just going to write it as 24. Keep it to the same number, significant figures. And 4. What do we get? 18. And the last 2. This is quite a long wire I was after. Okay, what's the value now? 15? Guys, oh, okay. So, relationship. If we stick to around 70, what happens when you add another one? Identical resistors. Halves. 70 divided by 3, roughly. You have a calculator? Divided by 4? Around that. But the main conclusion here, compared to this one, was what? Resistance in series. As you add more resistors in series, what happens to the overall resistance? Increases. When you add more resistance in parallel, what happens to the overall resistance? You've seen it, you've done the experiment, you see it, right? But formula now. N is the number of resistors, R is the actual value of one resistor. Yeah, like 70 or 68 in this case. And RT. R over N. Very good. Very good. Because that's R over N, 1, R over 2. So, for parallel, the total resistance is equal to the value of one of the resistors divided by the numbers. But this is only true for what? Identical resistors.